Okay, this problem gives you two rates to work with. This is, again, look at your units, it's gallons per hour, it's the rate pumped into the tank, and the rate at which removed is in R of T. Okay. Part A, is the amount of water in the tank increasing at time t equals 15? So when you see that word increasing, you should be thinking about that is your rate, which they give you. So I want to know, is there more coming into the tank or more coming out? So just use your calculator and compare W15, so just plug in 15 to W of T, and compare it to R of 15. And what you're going to notice is that R of 15 is a bigger number than this one. So there's more coming out than there is more coming in. So this is all you have to show them, or some people will do this. If you actually subtract the two and do it this way, you get a negative number. So regardless, you would this is your justification. And then you answer the question, no, not increasing. And it's because this is less than this, or you show that this is less than 0. Part B, how many gallons of water are in the tank at time 18? So I want the total amount, so I should be integrating these two, but in order to figure out how much is in the tank, I need to figure out how much comes in. This is the amount of water, total gallons. Again, think units. This is gallons per hour. The units on this is hours. So if I integrate that, that will give me total gallons coming in. But then I have to subtract off the total number of gallons coming out. But this, remember, will only give you the net change. I want to know how much water is in the tank at 18. There was 1,200 gallons to start with. Remember this idea of adding the initial condition? And they do want you to round to the nearest whole number. Use your calculator to punch that out, and I get 1310 gallons. Okay, part C. At what time is the amount of water in the tank at an absolute minimum? So I know I need to check endpoints, and my endpoints are going to be t equals 0 and t equals 18, and I need to check critical numbers. What I need to find the critical number is a function for the total amount of water. If you look back at part B, this is your general equation for the total amount of water. Now we did this for a particular moment in time at 18, but I could do this for any moment in time. So this is your equation for the total amount of water. So to find the absolute minimum, I need the critical points. So where the derivative of this is equal to 0, the 1,200 does not matter, it becomes 0. So really, to find your critical numbers, you're looking for where this, or where your rate is equal to 0. This is your derivative equal to 0. Use your calculator, and I get two values, 6.4948 and 12.9748. So I want to check these 2 points, these 2 points. I'm going to just make a little table. So at 0, at 6.4948, 12.9748, and at 18, what is the total number of gallons that I have? So at time 0, it told us that there was 1,200 gallons to start with. So I know that's 1,200. To figure out how much water is in the tank at 6.498, what you're going to do is, instead of this being 18, make both of these numbers be that 6.498. And add the 1,200, so punch this out on your calculator. I get 525. Do the same thing with this one, then do the same thing with this one, and I notice that the smallest number is this, so this is my minimum, and it does ask you for the time, so at t equals 6.498, and this is your work that shows your answer. Okay, lastly, part D. It says, after time 18, no water is being pumped in, but the water continues to be removed. I want an equation that can be used to find the value of K, which is when the tank becomes empty. So I want to know from 18 to K. The only thing that's happening is the water is being removed, okay? And I want to know when this is equal to 1310, because my answer from part A said there was 1,310 gallons. So when I want to know at what point is all of this going to get removed. So at time 18, I have 1,310 gallons. How much time does it take to remove all of this? So this is your setup.